In this lecture, we will go over the naming of the oxy acids and the oxy anions. So first, what are oxy acids? Oxy acids are acids that contain oxygen in them, in addition to having a hydrogen and another nonmetal. For an example, nitric acid, HNO3, is an oxy acid. And in this case, the name of this oxy acid is nitric acid. And just like all acid, if we were to take this substance and dissolve in water, it will break apart to produce the hydrogen ion. For an example, when dissolved in water, it will break apart to produce the hydrogen ion. And the rest of this, it then becomes negative. In this case, we will have NO3 and its overall charge will be -1 because the hydrogen is now becoming the cations. So here we are producing the hydrogen ion. And the rest of this is then called an Oxy Anion. When an oxy acid gives up the proton, the remaining of it is then referred to as an Oxy Anion. And in this case, the name of this Oxy Anion is nitrate. And nitrate is a polyatomic ion because it consists of 4 atoms in it, 1 nitrogen and 3 oxygen. And that is actually how we would name the oxy anion. Whenever we have an oxy acid, if the oxy acid were to give up the proton, the remaining of it would then become names in such a way that you have the 8T and 8Te ending to it. So in this case right here, the H ending on the nitric acid become the H ending. That's how we would modify the name to name the corresponding oxy anion that it's become. Now, there's many oxy acids that are out there, and here in this class, we will be teaching how to name all of this oxy acid. So technically, there's hundreds of oxy acid, and it's not a wise idea for us to memorize them all because that is a lot for us to remember. Instead, we will teach you the systematic way how to name the oxy acid and the oxy anions. But regardless of how we teach you, there's still some basic thing that you have to remember. So here in this case right here, to name the many oxy acid, we want students to commit to memorizing a few oxy acid and the chemical formula. And once we have memorized this common oxy acid already, we will be able to name the hundreds of all the oxy acid. So here are a few basic ones that you need to remember. First one, chloric acid. Chloric acid has the chemical formula of HClO3. And because this is an acid, when we take this and dissolve this in water, it will break apart to produce the hydrogen ion. And the rest of this then become -1 because the hydrogen is +1. So in this case, once HClO3 have broken apart to produce the hydrogen ion, the remaining of it would then be ClO3 and would then have a charge of -1. And to name this oxy anion, it is called the chlorate. So again, the H ending is now replaced with the H ending. That's how we would name the oxy anion from the name of the oxy acid. And another oxy acid to remember is nitric acid. Nitric acid is HNO3. And again, when we take this and dissolve this in water, it will break apart to produce the hydrogen ion, and the rest of this, it then become -1. And that would be NO3 with a charge of -1. And the name of this oxy anion is nitrate. Another one to remember is sulfuric acid. And please notice that sulfuric acid is different than hydrosulfuric acid. The chemical formula of sulfuric acid is H2SO4. And here in this case, we will notice that sulfuric acid has 2 hydrogen in it. So technically speaking, it actually produces up to 2 hydrogen ions. So these 2 hydrogen break apart to become 2 hydrogen ions. And notice how we put the 2 in front of it to indicate the 2 of this ion. And because each of this is positive 1, and now it produces both of it, that would then mean the remainder of this would then become negative 2. So here in this case, the charge of what is remaining would then be negative 2. And this would then be named as sulfate. And again, we got sulfate because we took out the ic ending in the name of the oxy acid and replaced that with the ate ending. Therefore, it becomes sulfate. And the next one is carbonic acid. And the chemical formula of carbonic acid is H2CO3. And this, like sulfuric acid, it has 2 hydrogen in it. So it can actually break apart to produce up to 2 of the proton. And the remaining of it would then be CO3, and now it overcharged in negative 2. And this is named as carbonate. So carbonic acid become carbonate. And here in this case right here, both sulfuric acid and carbonic acid are referred to as a diprotic acid. We call this diprotic acid to refer to the fact that they can give up 2 protons. Whereas chloric acid and nitric acid are then referred to as monoprotic acid. So mono refers to 1, so it produces 1 proton. And another oxy acid for us to remember is phosphoric acid. Phosphoric acid has the chemical formula of H3PO4, and in this case it has up to 3 hydrogen. So we would call this a triprotic acid. One molecule of phosphoric acid can give up to 3 hydrogen ions. And here in this case, once we take this and dissolve in water, it will produce 3 hydrogen ions. And the rest of this would then be PO4, and now its charge would then be negative 3. And this is named as phosphate. So these are the 5 common oxy acid for us to remember. Once we have memorized this already, I will teach you a systematic way how we would be able to name the rest of the other hundreds of oxy acid. So here's what happened right here. Certain nonmetals, such as chlorine, nitrogen, phosphorus, and sulfur, can form oxy acid, or a series of oxy acid containing different number of oxygen in them. For an example, if we were to be looking at the chlorine as the nonmetal in the oxy acid, it can form oxy acid with various amount of oxygen in them. In one instant, it may have 3 oxygen. In another instant, it may have 2 oxygen, or 1 oxygen, or 4 oxygen in them, for an example, as follows. So the nonmetal here is the chlorine, and here in this case 3 oxygen. And similarly over here, except there's now 2 oxygen. And this will have 1 oxygen, and this one have 4 oxygen. So there's many derivatives that consist of the same nonmetal. However, they have different amount of oxygen in them. And these are different substances. And we need to be able to name all of them to distinguish among them. And how we would name them would be as follows. So here in this case, HCl3 is named as chloric acid. HCl2 is chlorous acid. And HClO is hypochlorous acid. And HCl4 is called perchloric acid. Now, there's differences among them, right? And here in this case right here, it's quite difficult because there's now up to 4 different names that we have to remember. And if we were to now have a different nonmetal in here, then we'll end up with a lot of this ic, us, hypo, and per, and so on acid as well, which add up to quite a whole lot. So there's a lot of oxy acid for us to remember. Therefore, instead of memorizing all of them, we will be teaching you the systematic way how to name them. And the method that we are about to go over will not only teach us how to name this different oxy acid right here, but will also to be able to name this oxy anion that they produce as well. So let's go over this method. How we would name the oxy acid and the oxy anion systematically. So this is what we do first. First, we identify the most common oxy acid and its chemical formula. And this most common acid right here was the list of the 5 oxy acid that we asked you to remember on the previous page. And once we have remembered this already, this then serves as the starting name. We will then change the starting name depending on how many oxygen that is present in the derivative, according to this table below. For an example, the most common one, that is the starting name in here. If it is an oxy acid, then you have the ic ending on it with the word acid. When this oxy acid right here has lost its proton to now become the oxy anion, to name the oxy anion, we take the ic ending and we change that into this a ending. So that would be the starting name. And that's how we see the chloric acid become the chlorate, as well as the sulfuric acid become the sulfate, because the ic is now changed into the A. Once an acid, it becomes in the oxy anion. To now name the other derivative with different amount of oxygen in them, for example, going back to this different derivative. Now, so we know that HClO3 is chloric acid. How would we name HClO2 or HClO or HClO4? Let's now go over this table. So here is how we would modify them right here. We start out with the most common one, and please remember however many oxygen that the most common one would have. If we were to have a derivative in which we have 1 oxygen fewer than the most common one that we have memorized a chemical formula, then to name it, we change the ic ending into the us ending. And if we were to have an oxy acid that now have 2 oxygen fewer compared to the most common one, to name it, we now add the prefix hypo in front of it and still keep the us ending to it. Versus if the oxy acid now have 1 oxygen more compared to the most common one, then we would add the prefix per in front of it and still keep the ic ending. So that's how we would be able to name the different derivative of the oxy acid that now have different oxygens compared to the most common one. And similarly, to now name the oxy anion, then again, the most common one will have the A ending. And if we were to now have an oxy anion that is now 1 oxygen fewer compared to the most common one, the H ending would now become the H ending. So basically, an us acid become an H oxy anion. And if the oxy anion would have 2 oxygen fewer compared to the most common one, then now we add the prefix hypo in front of it. So us become I. Ic become A. And here in this case again, ic become A. And if we have 1 oxygen more, then we add the prefix per in front of it. So using this method right here, we would be able to name many derivatives of the different oxy acid. And we do not have to remember as much. Let's now try a few examples. How would we name all of this oxy acid? So in this first case right here, we can see that this first 4 oxy acid right here had the chlorine as the nonmetal. And now we should recall that we know that when it comes down to having a chlorine as the nonmetal, then the most common one have 3 oxygen in them. And that's the one that we have remember. And this is the chloric acid. To now name the ClO2, so here in this case right here, it still is an oxy acid because it still have the hydrogen in it. If the substance still have the hydrogen on it, it is the oxy acid. So here in this case, to name this oxy acid, we see have 1 oxygen fewer compared to our most common one because it has only 2 oxygen. So here in this case right here, our 1 oxygen fewer compared to the most common one, that would then become the us ending. So therefore, this will now become the chlorous acid. And for the HClO, it now have 2 oxygen fewer compared to this most common one. So this is the starting, or the most common one. And now have 2 oxygen fewer. Then to now name that, we would now add the prefix hypo in front of it and still keep the us ended. So in this case, this becomes hypochlorous acid. And for the HClO4, this one will have 1 oxygen more compared to the most common one. So it would be in this box right here. We will add the prefix per in front of it. So this becomes the perchloric. So you still have the ic ending to it, followed by the word acid. And now, how will we then name the oxyanions that they produce? So here in this case, once the hypochlorous acid have given up the proton already, it will now become ClO3 with a charge of -1. Now, it's important that we also remember the charge of this as well. And by knowing the structure of the acid and understand how an acid works, we will be able to produce and remember the charge of the oxyanion. So here in this case, because this have 1 proton in it, after you give up this proton already, the rest of this will then become -1. So this is why this is now -1. And to now name this would be called the hypochlorite, because as follows: when an us acid give up the proton, then the us, to name the corresponding oxyanion, we change the us ending into the ite ending. So therefore this becomes hypochlorite. And similarly, when we have chlorous acid, that is this ending right here. Once a chlorous or an us acid have given up its proton already, its ending would now become ites. So this would be called the chloride. And with the ic ending, once it have given up the proton to become the oxyanion, this will be named as the chlorate with the 8 ending. And lastly, once perchloric acid have given up the proton already, it becomes ClO4 and the charge is -1. So all of them are -1. And now this becomes the perchlorate. So that's how we will name the different derivatives of the oxy acid and the oxyanion. Let's now try a few more examples. So here in this case, to name these 2 acids, how would we do it? So here in this case, we recognize that right now in this case right here, they have the same nonmetal and both of them are nitrogen. And when nitrogen form the oxy acid, the most common one have 3 oxygen in them. So this is our most common one. And therefore this is the nitrous acid. Once a nitrous acid have given up its proton already to become the oxyanion, it would then become the 8 ending. So therefore NO3 would then be named as nitrate. And now the HNO2, you have 1 oxygen fewer compared to the most common one. So therefore this would then become the this would be the nitric acid. And this would be the nitrous acid. And this one would then be nitrite. Once nitrous acid have been given up the proton already, to name the corresponding oxyanion, again, us become 8, ic become 8. And lastly, another example. How will we name these 2 substances in here? And again, identify your most common one. In this case, when the sulfur is a nonmetal, 4 oxygen would then be the most common one. And this is our sulfuric acid. And once sulfuric acid have given up the proton already, it becomes SO4. And please notice that the charge on SO4 is actually -2. because it gives up 2 protons. And if 2 protons, each is positive 1, then the resultant of what it remains would then be negative 2. So here in this case, this would then be sulfate. Now we do not call this sulfurate, but we simply call this sulfate. So we actually take out a little bit more than thus the H becoming the A. But sulfuric acid become sulfate. And to name this now oxy acid, we can see they have 1 oxygen fewer compared to sulfuric acid. So in this case right here, to use this name, have 1 oxygen fewer, it will have the us ending to it. So therefore this becomes sulfurous acid. And this would then be sulfite. So that's how we would name all of the oxy acid. And now, before we move on, let's now go back to one of this example in here. This first one. Chlorine. In this case right here, we see the oxy acid. The non-manner that is present in this oxy acid right here is the chlorine. Instead of the chlorine, we can have another halogen in it, and that would still form the oxy acid. For example, instead of the chlorine, we can have the bromine, and we can also have the iodine in here, and that would still form the oxy acid. And now to name the oxy acid, when we have a different halogen in here, it is actually exactly similar to the naming of the chloric acid. So for an example, if we were to have a bromine in here and now have HBrO3, so the halogen is the bromine rather than chlorine, then to name this would now become the bromic acid. If it's the chlorine, it's chloric acid. If it's the bromine, it is now bromic acid. And if we were to now have HBrO2, that's similar to this one, except instead of the chlorine, we now have the bromine. Then now this would be known as the bromous acid. And similarly, if we were to have, in this case, HBrO, this would be named as hypobromous acid. So that's how easy it would be. And similarly, if we were to have in here, let's say we have here an iodine, HiO4. So here in this case, the iodine instead of the chlorine. If we were to have HClO4, this is perchloric acid. If we now change in the chlorine into the iodine, this will now become the periodic acid. So any of the halogens, except for the fluorine, can form oxy acid. So basically, chlorine, bromine, and iodine can form oxy acid. Not fluorine, because fluorine cannot exceed octet. So all of this can form oxy acid, and they name very, very much similarly. So this is why that once we have learned how to name the chloric acid and its derivatives, then we will be able to name the other oxy acid with a different halogen. And now let's go over naming the polyprotic acid. What are polyprotic acid? Polyprotic acid are basically acid that can give up multiple protons. For an example, sulfuric acid, carbonic acid, and phosphoric acid. All of this can be collectively referred to as polyprotic acid. So in this case, this is sulfuric acid. And sulfuric acid is a diprotic acid or a polyprotic acid. So sulfuric acid have 2 protons in it. And apparently, these 2 protons are actually not broken up at the same time when we dissolve this in water. So if we were to now take this and dissolve this in water, these 2 hydrogens right here will not be falling off into the proton at the same time, but one fall off followed by the other. So basically there is an intermediate in the middle that still have 1 proton in it. So for an example, when we take this and dissolve this in water, the first proton will fall off. And the rest of this would then become HSO4. And now, HSO4 would then have a charge of -1 on it. And this is an intermediate that can actually exist. And because it exists, therefore we need to be able to name it. And once we have HSO4 negative already, it can further give up another proton to now become SO4. And the charge of SO4 is now -2. So again, to make sense out of this is -1. And if something is -1, they lose another proton, then the rest of it would then become -2. So we have seen already that this is sulfuric acid. And to name SO4 -2, this is sulfate. So how would we name this intermediate right here in the middle? Because it actually exists, so therefore we need to be able to name it. And apparently, naming this is not that difficult. This is called hydrogen sulfate. So as long as it is negative, because it is an Oxy Anion, we can call that with the name it with the 8 ended. And in this case, there's a hydrogen in it. So therefore we call this hydrogen sulfate. Anytime that we have hydrogen something, we can short name this as bisulfate. So if there's one hydrogen, we can rename that hydrogen with bi. And in this case, bisulfate. So that's how we would name the intermediate in the middle. And similarly, carbonic acid has 2 protons. This is carbonic acid. And it is a diprotic acid. It can give up 2 protons. So when it gives up the first proton, the remaining of it then become HCO3 with a charge of -1. And this actually exists. And HCO3 -1 can further give up another proton. And when it gives up the next proton, the remainder of it will then be CO3 with a charge of -2. And we have learned already that this is named as carbonate. So how would we name this intermediate here in the middle? Because it actually exists. And similarly to the example we have seen above with the hydrogen sulfate, this is now named as hydrogen carbonate. Or it can be short named or common name as bicarbonate. Bicarbonate and hydrogen carbonate are the same thing. And moving on to this next example. H3PO4. This is phosphoric acid. Phosphoric acid is a triprotic acid, meaning it can give up to 3 protons. And again, these 3 protons do not fall off at the same time, but one after the other. So when we take this and dissolve in water, it will break apart to produce the first proton. And the remaining of this will become H2. We have 2 hydrogen left with PO4, and now its charge will then be -1. And once we have this intermediate already, it can further give up another proton. And now the remainder of it will become H1 hydrogen left with PO4, and then now charge become -2. And this can further give up another proton to finally become PO4 with a charge of -3. And we have learned already that this is now named as phosphate. There are now 2 intermediate in the middle that we need to be able to name because both of them exist. So how would we do that? And the answer is actually quite easy. In this case, because this is an Oxy Anion, we can call this as a phosphate and have 2 hydrogen on it. So therefore we will call this as dihydrogen phosphate. Whereas this one, it still is an Oxy Anion, so therefore it can have the H ending to it. And in this case, it can be named as phosphate and now have only 1 hydrogen on it. So therefore we name this as hydrogen phosphate. And hydrogen phosphate can also be named the common way as biphosphate. So only when it have one hydrogen on it that it can be named with the common way with the word bi. And moving on, we will be skipping the naming of the hydrated ionic compound. And we will see this be named later in Chem 400.